Hello, I am Matteo Dicenzi, a robotics engineering student collaborating with the Istituto Italiano di Tecnologia. Today I'm going to present our work entitled Recognizing Italian Gestures with Wearable Sensors. The work aims to use wearable sensor to collect and recognize 12 natural and social gestures. To collect a novel dataset of social gestures, we will employ the humanoid robot iCab, which will provide the same social interaction to every participant. Data will be collected through the custom-made inertial glove worn by the participant's right hand during their experiment. The gestures are extracted from the Italian culture and are a well-known example of gestural communication. They are characterized by a well-defined gesture meaning pair. On the left, we provide the 12 gesture classes considered in this study. A complete gesture selection can be seen in the video at the provided link. The figure on the right depicts the experiment scene, where iCab guides participants to reproduce the gestures that they see on the monitor on the right. As a reference, we provide a video extracted from one single gesture execution. Experiments involved 31 participants. Each of them performed 124 gestures per class, for a total of 1388 examples. Each gesture example contained 110 inertial features. For reference, we provide on the right the evolution of the features of the index intermediate phalanx during one specific gesture example. Once collected the dataset, we removed 1.3% of gestures, as performed outside a time interval that was signaled by an emitted sound. Assuming that the relevant motion in each trial corresponds to the gesture execution, we extracted those portions through an automatic segmentation algorithm. The algorithm is based on a threshold that was estimated when the hand was held steady in the initial rest position. As usually happens in these cases, data are normalized, considering the maximum and minimum values measurable by the glove. Since the following model requires all input gestures to share the same duration, we pad the data, considering as reference the longest gesture duration. We selected a long short-term memory recurrent neural network for its capability to learn time-dependent information. The model is characterized as described above. In particular, the masking layer allows us to exclude the values added during the padding. To prevent from overfitting, we consider regularization techniques such as dropout and L2 kernel regularizer. Thanks to the final softmax activation function, the model, which takes in input the training set, returns a vector containing the probabilities to belong to the 12 classes of gestures. The model is trained and evaluated offline, providing in input batches of complete gesture executions. To evaluate the performances from a statistical point of view, we consider a k-fold cross-validation approach, where the dataset is randomly divided into 3 sets: the training set, the validation set, and the test set, as described above. The overall accuracy, which is the mean of all the fold accuracies, is equal to 87%. The figure shows one of the fold confusion matrices, where the X and Y labels depict the gesture classes. On the diagonal of the matrix, we can find the correctly classified gestures, which represent 93% of all the possible classifications. In conclusion, we collected a dataset of natural and social gestures via experiments organized as human-robot interactions. We proved that, despite the social nature of these gestures can be correctly recognized with a fair accuracy. In future developments, we will implement an online version of the model. Thank you for your attention.